So when we talked about these subnets, we sort of laid it out like this. Before we did this, we had this important thing. So right now we're incentivizing innovation. We don't want that ever to die. Like we need that innovation to happen, because otherwise, I mean, what's really unique about an open quantum platform? Like, why do people need something like BitTensor for it? You could just, like, anybody could scale up a large subsidized, compute warehouse. What we need is the two doing a dance together. And so the idea with the current hypothesis is that 63 continually challenges people to invent new provocative ways to solve bigger problems more universally, and that technology, as it is being invented, makes its way then into, it essentially graduates into 48 and becomes a backend that the end users can choose to run on there. And so essentially you're building your models on 63, then graduating your model to 48, where it can just be run and call it like a Docker container, essentially, by these operators servicing requests. And so it creates a huge opportunity for us to both incentivize, again, doing smarter things, continuing to push the state of the art of technology and enable that kind of future we were talking about, and also to incentivize operating. As we sort of looked at it, there was really no way to do it other than having two subnets, right? Otherwise, you sort of had to choose which of those things you were incentivizing.
And that's a pretty complete
I don't know if that. Yeah, and I do suspect that this is a brand new idea. I think people we've thought about this a thousand different ways. I think people will look at this and say, yeah, that probably makes a lot of sense. I know there's going to be a lot of questions about the details, and the truth is that if we've learned anything about BitTensor, it's that you have to be sort of enter into everything with a plan. And then get ready to get punched in the face, because you're going to learn that your plan is going to hit very motivated people working very hard. And so we do have a solid plan on how we're going to do this. We have a sound model for how it's all going to work. We also imagine that as we start going, we're going to quickly learn and iterate and calibrate this thing to really be a well-oiled machine.